Hey guys, welcome to the NCEA Level 3 Calculus differentiation paper from 2020. The way this video is going to work is I'm going to go through each question, explain to you guys what you need to do for achieve merit and excellence. Best way to watch this video is to pause the video at the start of each question, have a go by yourself, and then unpause the video just to see how I approach the questions. Now you might have a completely different way of doing these questions, and if you are happy with it, that's absolutely fine. So without further ado, let's get started. All right, guys, let's go to question 1A. So question 1A, as always, starting with a nice differentiation question. So we're going to differentiate this. What do we got? Y dash is equal to, bring the power in front. So it's going to be 5, 3x minus x squared to the power of 5, take away 1, so that's going to be 4. And of course, I've always got to multiply by the differentiation of whatever's inside the bracket here. So in this case, it's going to be 3 minus 2x. And that's something people just tend to forget all the time. Yep, that was my kid just being himself. Cool. As I was saying, what you got to do is you got to actually make sure that you don't forget to differentiate the inside of the bracket, which people tend to do a lot of times. Cool, so that's basically it for this question. You don't need to simplify any further, just stop right there, and that's going to get you an achieved. All right, let's go to question B. So question B is we need to find the gradient of the tangent to this curve. So the first step is to differentiate, and then we're going to try and find out the gradient. Okay, so what we're going to do is, because I'm actually trying to find the gradient, I'm just going to rewrite this as f of x. And I've got 3 sine 2x plus cos 2x, which is the original equation. And I'm going to differentiate this. Now sine 2x differentiates to cos 2x. And of course, I've got to multiply by the differentiation of whatever's inside the bracket. In this case, it's 2 plus cos 2x differentiates to sine 2x, negative sine 2x actually. And once again, I've got to multiply by the differentiation of whatever's inside the bracket, which is going to be 2 in this case. So f dash of x could be rewritten as 6 cos 2 of x, sorry, 2 of x, 2x, plus, no, not plus, minus 2 sine 2x. Now at this point, we are trying to find the gradient when x is equal to pi over 4. So we're going to put pi over 4 in here as, just substitute it and figure it out. So what I'm going to do is just go straight into the calculator, run. Just want to check that my, what do I call it, shift setup. Just want to make sure that my angle is actually in radians because I'm using pi over 4. So once that's done, a couple of little tricks here. So what you could do is you could just go shift pi over 4. That gets stored as the answer. So what I'm going to do is I'm going to go 6 times cos of 2 times the answer, because answer is equal to pi over 4, minus 2 times sine of 2x, so 2 times pi over 4 again. And I get negative 2 for this. So for this question, you've got to get correct derivative and the gradient to get an achieved. So yeah, it's basically you've got to do both of the things right there. All right, so let's go to question C. So question C, what we've got is to differentiate, and we're trying to find the stationary point. Because we're trying to find the stationary point, we know that the gradient has to equal 0. So I'm going to write down f of x as x1 plus ln of x. Now looking at this, I can kind of see that I've got to use quotient rule. So if u is equal to x, u dash is equal to 1. And if v equals 1 plus ln of x, v dash is equal to 1 over x. So once that's good, we're going to put that into the quotient rule. So f dash of x could be written as u dash v minus uv dash divided by v squared. So u dash is 1 times 1 plus ln of x minus x multiplied by 1 over x, and the whole thing is divided by 1 plus ln of x squared. Now we know that the gradient has got to equal 0, so because of that we can kind of, okay, I'm just going to do this slowly. So because gradient is equal to 0, I'm going to put the left hand side equal to 0. Now 1 times 1 plus ln of x is just 1 plus ln of x, and then x times 1 over x is just 1, and that whole thing is divided by 1 plus ln of x squared. Now cross multiplying it, so I am actually bringing the 1 plus ln of x squared to the right hand side, and because it's being multiplied by 0, that's going to end up being 0, but I'll write it down anyway. And all of this is equal to ln of x, because 1 minus 1 is 0. Now 0 times 1, that just goes to 0, and then we've got 0 equals ln of x, which means x is equal to 1. Now if you do kind of go, well, how did I get that real quickly, you can just rewrite this as e to the power of 0 equals to x, and on your calculator you should be able to just go e to the power of 0 is equal to 1, because remember that any number to the power of 0 is equal to 1. So correct solution with correct derivative gets you a merit. A correct derivative gets you an achieved, so that's going to be right about there. Awesome, guys, good pace. So let's go to the next question. Cool, so the next question, what we have got here is an equation. Got an equation, and then we've got to try and find the equation of the tangent for that particular one. Okay, so let's actually break this down, right? So what we've got here is x is equal to pi, and then y is equal to minus pi squared. That's the point that we're looking at. Now we also got f of x. F of x is equal to x squared cos x. And I can straight away see that this is going to be u times v, which means I'm using a product rule. So u is equal to x squared, u dash is equal to 2x, v is equal to cos x, v dash is equal to negative sine x. So putting this in gradient, so gradient function is going to be u dash v plus u v dash, and so what we've got here is 2x cos x plus u is x squared multiplied by negative sine x. So now that we've actually found the gradient function, we need to actually find the gradient at pi. The gradient at when x equals to pi. So what we're going to do is we're actually going to put pi and figure out what the gradient is. So we've got 2 times pi, cos of pi plus pi squared negative sine of pi. And kind of looking at the equation. So if you look at the final equation, there is a pi squared and a pi there. So I'm going to try and leave the gradient in terms of pi as much as possible, rather than trying to do it in decimal points. So the first thing is I'm going to get rid of the cos pi. So if you look at cos pi is negative 1. So I'm going to get 2 pi multiplied by negative 1 plus pi squared, and then I've got negative sine pi. So negative sine pi is equal to 0. So because that's equal to 0, I don't really need to worry about that pi squared, and I've got the gradient here as negative 2 pi. And now it's just a matter of putting all of this into a straight line equation. Now a straight line equation is y minus y1 equals m times x minus x1. And we also have all the points. So we actually have our gradient, which happens to be minus 2 pi, because that's what the gradient is at pi. We have x1 value, which is pi. And then we also have the y1 value, which is minus pi squared. So putting it all together, we're going to get y minus negative pi squared equals negative 2 pi multiplied by x minus pi. So at this point, what we've got is we're going to have to simplify. So we got y plus pi squared equals negative 2 pi x plus 2 pi squared. And if you look at the original equation, we just got to bring all the pi squareds to the right-hand side and everything else to the left-hand side. So we're going to get y plus 2 pi x equals 2 pi squared, take away pi squared. And now this kind of nicely simplifies to the equation that we actually want. And that's basically it. So grades wise, correct proof with correct derivative gets you a merit, and a correct derivative gets you an achieved. So that's probably somewhere here. All right, guys, so let's go to the next question. All right, so we've got question E. So what we've got here is a couple of things, right? We're trying to find the maximum volume of the cylinder. Now, the cylinder is going to change. Like, what do I mean by that? Like, see, for example, if the cylinder looks like this, I'm going to try my best attempt there. So we've got these like different kind of shapes of cylinders that's actually happening, right? Now, we know the volume of a cylinder. That's actually given in your formula sheet. So volume of cylinder is actually equal to pi r squared h. Now let's actually have a look at the cylinder. If we look at the radius, right, the radius of the cylinder is actually from here to this part here. So that's not too bad, all right? That's not too bad at all. Now we've got, in fact, you know what I'm going to do? I'm going to actually put that in the middle just to show you guys how this kind of works out nicely. So that's the radius, right? The next thing is looking at the height of the cylinder. Now the height of the cylinder is this whole thing right there. Okay, I hope that kind of makes sense. So we've got our height there, and then we've got our radius there. Now we need to come up with some sort of equation where we don't have r or h. All right, so you can't have like r and h in your cylinder and then differentiate it. So what you're trying to do is you're trying to get rid of one of those elements. Either one, it doesn't really matter. And so the only other thing that we have is this particular thing here, which is the sphere has a radius of 20. Now the sphere has a radius of 20. That basically what it means by is, I'm going to kind of put that here, sphere of radius 20. Wrong color. Let's try light blue. So that from the center of the cylinder to the top, like one of the top corners of the cylinder, that measurement there is going to be 20. Okay, and I hope that kind of makes sense. Because if you think about it, right, from the center of the cylinder, it's going to the edge of the cylinder, and that edge of the cylinder is going to be on that edge of that sphere, which means the distance is going to be 20. Now that's pretty much all we're going to need to use, because what we're going to do is we're going to take this little triangle that we've just created in there, which is basically 20, and that's r. Now this length here is not going to be h, but it's actually half of h. So we can rewrite this as h over 2. And I guess this is the first step that you need to do for this question, because this is going to allow us to get rid of one of the elements and then differentiate it. And we are going to get rid of r. And I'll show you why we're going to get rid of r. Now, let's have a look at this part here. This is a right angle triangle. So we can actually say r squared is equal to, not r squared, equals r squared plus h over 2 squared equals to 20 squared. And I guess the reason I said we're going to get rid of r squared is because we've got an r squared here, and we've also got an r squared in the formula of the volume of cylinder. So I'm going to rearrange this as r squared is equal to, now 20 squared is 400, minus h squared is h squared divided by 2 squared, which happens to be 4. So I'm going to leave that r squared as 400 minus h squared over 4. Cool, which means our volume of cylinder now is going to equal, maybe I should just move this here. So now our volume of cylinder, what we're going to do is we're going to go, instead of r squared, we're going to put in 400 minus h squared over 4 multiplied by h. So our what happens then is we've actually got, well, how do I do this? 400 times pi times h, which is 400 pi h minus pi h cubed over 4. Now this is pretty much our formula for our volume of cylinder. So now it's just a matter of differentiating it, putting it equal to 0, and actually working out the maximum possible volume. So when we differentiate the volume, we're going to differentiate it with respect to height. So we're going to get 400 pi minus pi times 3h squared over 4. And of course, this is now equal to 0 because we know that max happens when, so max equals to 0, sorry, max is when dV dH is equal to 0. And yeah, it's always nice to write that little statement there. 400 pi minus pi 3h squared over 4. Now pi is a common factor, so I'm going to take it out. And I've got 400 minus 3h squared over 4. When pi goes to the other side, 0 divided by pi is just 0. So this is going to become 0 is equal to 400 minus 3h squared over 4. We are bringing the 3h squared over 4 to the left-hand side, which makes it positive. And this is now equal to 400. And now it's just a matter of manipulating everything. So 400 times 4. And h squared is equal to 1600 divided by 3. Or I can actually say h is equal to square root of 1600 divided by 3. So it is at this point, you've got to actually put that in the calculator. So we've got 1600 divided by 3 equals to that. And square root of that is equal to 23.1. Now, unfortunately, we're not finished with this because we are asked to figure out what the maximum volume is. And our volume equation, we're going to use the one in terms of h. So that's pi multiplied by 400 minus h squared over 4 multiplied by h. So our maximum volume is equal to, and again, you notice that I've not actually gotten rid of my answer from the calculator, because that means I can just do something like this: pi times 400 minus answer squared divided by 4 and multiplied by answer again. So that gives me 19,347. 0.2 centimeter cubed. So yeah, I guess the key thing for this question is getting that initial equation right here. Like this part is the most important part, because once you get that part down, then it's just like bread and butter. It's like get rid of a variable and then differentiate, put it equal to 0, solve, and then you're pretty much good to go. Cool, guys. So basically, grades-wise for this question, you're looking at units not required, so that's great. Correct solution with correct derivatives gets you an excellence. Correct value of r or h with correct derivatives, so that's up to here, is going to get you a merit. And then finally, dVdh or dVdr is going to get you a achieved. So that's actually way down here. Cool. That is basically question 1, guys. We move on to question 2 now. All right, guys. So on to question 2. So with question 2, what we've got here is a quotient rule. Once again, I'm just going to kind of put that as u is equal to tan x, and v is equal to x cubed. U dash is equal to sec squared x, and v dash is equal to 3x squared. So it's just a matter of now putting it all together. So we can actually say f dash of x is u dash v minus u v dash divided by v squared. So we've got sec squared x multiplied by x cubed minus tan x multiplied by 3x squared. And that whole thing is now divided by x to the power of 3 squared. Now you can actually leave your answer like this, folks. Like you don't have to actually simplify it any further. So that's going to get you an achieved for this question. Cool, we go to the next question. So question 1b, what we've got is we've got the value of the car, and they're asking basically which this car is changing when it's 8 years old. So we got to find dv dt, and then we got to substitute t as 8. That's pretty much it. So I'm going to write down the equation here. So I've got 17,000 e to the power of negative 0.25 t plus 2,000 e to the power of negative 0.5 t plus 500, which means dv dt is, I mean, you guys know with the exponential equation that we just write down the equation as is. But we've got to multiply by the differentiation of the power. In this case is negative 0.25. And then in the next one, we've got plus 2,000 e to the power of negative 0.5 t. And once again, multiplied by the differentiation of that, which is negative 0.5. Super annoying, these questions, right? Like, why would you even... So, first the 500 just disappears into 0. The next thing is t is equal to 8. So the rate at which things are changing is we're going to put dv dt equals negative 0.25 multiplied by 17,000 e to the power of negative 0.25 times 8 plus negative 0.5 multiplied by 2,000 e to the power of negative 0.5 times 8. So just literally just putting this in the calculator, folks. Yeah, annoying. So many things. Times 17,000 times e to the power of negative 0.258 times 8 plus minus 0.5 multiplied by 2,000 times e to the power of negative 0.5 times 8. So what I'm getting is negative 593.550. So because it's negative, it's actually a good idea to kind of state like it's actually decreasing. So that's what that negative means. So it's actually decreasing by 593.50 per year. And again, like when I look at the answer schedule, let me see if I can show you guys. So as you guys can see, with the answer schedule, all they're looking for achieved is just the correct answer. The units are not required, and the interpretation is not required as well. So you don't really need to worry too much about the interpretation. So you could potentially just leave it at here and still get an achieved for it. All right, so let's go to the next question. So the next question, find the x-coordinates of any stationary points. So we are differentiating and then putting it equal to 0 and finding out what the stationary points are. So it looks like we've actually got a product rule here where u equals to that and v is that. So I'm going to kind of break it down. So u is equal to 2x minus 3, which means u dash is equal to 2, and then v is equal to e to the power of x squared plus k, which means v dash is equal to e to the power of x squared plus k, and of course I've got to multiply by the differentiation of this, which is 2x. Cool guys, so now I'm going to put this into f dash of x, which means I've got u dash of v plus uv dash. So u dash is equal to 2 e of x squared plus k, plus u is 2x minus 3 multiplied by 2x e to the power of x squared plus k. Now I know that the gradient is equal to 0 for stationary, so I'm just going to put that here, f dash of x equals to 0 for stationary point. And again, I don't know, like some people say you don't actually need to write this, but it's just kind of like good habit to kind of keep for calculus. So, all right, so what am I going to do? I need to actually figure out a way to get a common factor out and see if I can get to some sort of solution. And I can see straight away that ex squared plus k and ex squared plus k is a common factor. So I'm going to take that out. So what I'm going to end up with is 2 plus 2x minus 3 multiplied by 2x. I guess I could have taken that 2 out as well as a common factor, which I probably should. So I'm going to get 2e of x squared plus k, bracket, what do we got? 1 plus 2x minus 3 multiplied by x. So kind of keep on going with this. What I have got here is 0 is equal to 2 e to the power of x squared plus k multiplied by 1 plus 2x squared minus 3x. So basically what I've got is these two brackets are multiplying each other to equal 0. So I can say the first bracket, 2 of e x squared plus k equals to 0. And then I can say, or 2x squared minus 3x plus 1 equals to 0. Now, with this particular one, 2e to the power of x squared plus, that's an exponential graph, and it never actually equals to 0 because there's no vertical or horizontal, there's no vertical shift. So this graph is going to pretty much look something like this. And so it's never going to actually equal to 0. So we just kind of ignore it completely, and we just focus on this quadratic here. And because it's a quadratic and we've got the calculator, I am not going to be sitting there trying to use like quadratic formula or anything like that. Just going to go straight into polynomial, and I'm going to just punch in these numbers, get my values, and get out of it. So x is equal to 1 or 0.5. So going into the answers, I would actually kind of say that in this case, like 2e x squared plus k has no solutions, as it is always positive. So it is actually worth mentioning that. But however, once again, checking the answer schedule, they're saying that reference to that is not required. They're just looking for correct solution with correct derivative to get a merit. So you're going to get a merit from that, and the correct derivative is going to get you an achieved. Okay, so let's go to the next question. Okay, so what we've got here is we've got a lovely classic rate of change question here, and kind of got to work through that. Now, unfortunately, I don't have that picture there. I try to find it. Once again, I suffered miserably. Or actually, no, this one, I'm not gonna lie, I didn't actually look at it. So I guess we've got a rocket that's kind of like launching, and something's gonna happen, like something like that, or 4.8 t squared. That's a positive graph, so it's probably gonna look something like this. Anyway, so what we're looking at is, it's actually fired vertically upwards, right? So it's actually kind of going there, that way, there. So that's going to be the height of the rocket. We don't know what the angle is, so we're just going to put that as theta for now. So straight away you can see that we've got a nice little equation kind of set up there, because what do we have here? We've got tan theta is equal to opposite, which is height, divided by adjacent, which is equal to 500. Now, if you look at it, the question itself is asking, find the rate at which the angle of elevation of the rocket is increasing. So you're asked to figure out what is d theta dt. And for those of you guys that know that that have been kind of watching some of my rate of change questions, is that I always write down what's being asked. All right, so d theta over dt is what it's being asked, and I look at what can I actually use to figure out that. Now, I've got this right there, which is the height of the rocket with time. So I know that if I differentiate that, I'm going to get dh dt, which means if I multiply, I've got to multiply by something, and I need to have d theta at the top and dh at the bottom, because what that's going to do is, hopefully you guys can see that when I actually do this, the dh actually kind of like disappears. And in some ways, this part right here, I can actually get from here, the dh d theta. How do I do that? Well, let's have a look. So we got tan theta is h over 500. So we can rewrite that as h is equal to 500 times tan theta, which means dh d theta is equal to 500 times sec squared theta. And as for dh dt, we know that dh dt, well, let me actually do that first part there. H is equal to 4.8 t squared, which means dh dt is equal to 9.6 t. So with that in mind, I'm just going to go ahead and just substitute everything. And what does it say? Find the rate at which when the rocket is 480 meters above launch point. So we do need to find theta for that, because the question is actually asking when the rocket is at 480 meters high, right? So we actually need to know what that theta is. So we do need to find that. So we're going to find it out. So we're going to go tan theta is equal to 480 over 500. So theta is equal to inverse tan of 480 over 500. What is that going to give me? So inverse tan of 480 divided by 500, that's going to give me 0.76. So now I've got the angle. Now I'm actually going to go work out what the d theta dt is. Now dh dt is 9.60 multiplied by dh d theta. Now that's actually 1 over 500 sec squared theta. Now sec squared theta is 1 over sec squared is just cos squared. So I can rewrite this as 9.6 t multiplied by cos squared theta over 500. Now here's a funny thing, right? I've actually got cos squared theta. I mean, I've got theta there, which is kind of covered. But what I don't have is I don't actually have t. So I need to figure out what is t when the height is 480 meters. Now, to do that, I'm going to go to my equation, which was h equals to 4.8 t squared. And I'm going to put h as 480, which equals to 4.8 t squared. So t squared equals 480 over 4.8, which is 100. And t is equal to 10. Okay, cool. So now I got that 10. And go in here, 9.6 times 10. Multiplied by cos squared of 0.76 over 500. That's going to end up much better with calculating my answer. So 9.6 times 10 multiplied by cos theta, which is cos of, I'm going to put that as cos of answer because I didn't get rid of it. Missing something, 9.6 theta times cos squared divided by 500. And that's actually giving me 0.0999. That's 0.0999 radians per second, is it? Per second, yeah. Oh, wow. I did not see that. This is actually an excellence question. Correct answer with correct derivatives gets you an excellence. I thought this was a merit question. D theta dt gets you a merit, which is here. This gets you a merit. Dh d theta gets you an achieved. Did not see that coming. Thought it'd be a much, yeah, surprised me. All right, guys, so let's go to the next question. All right, guys, so we've got a curve that is defined by this parametric equation, and then we've got a point that lies on this curve, right? And the only thing that we know is that when this equation is double differentiated at point P, it's equal to 2. So we're just gonna do it one step at a time, right? Like, because like if think about it like this, so we've got some sort of function, right? And then there's a point P on this function. Let's put it like this: f double dash of P equals to 2. That's kind of like the idea that this question's actually given us so far. And with the information given, we've got to actually try and figure out what that point is. So I guess the logical thing is to actually to differentiate. So we've got x is equal to ln of t. So when we differentiate dx dt, we're going to get 1 over t. Then we've got y is equal to 6t cubed. So we're going to differentiate dy dt, and that's going to be 18t squared. So our first step is to put dy dx together. So dy dx is equal to dy dt multiplied by dt dx. So we're going to get 18t squared multiplied by t over 1, which is going to give us 18t cubed. Now our double differentiation part, and again, if you forget this, this is actually, it is available in your formula sheet. Let me just show you guys where it is available. So in your formula sheet, right next to Norris theorem, there it goes. Underneath all your integration stuff, you're going to find the parametric function. So basically, we just did that first part. Now we're going to copy the second part of this equation and kind of work through from there. So the second part of this equation is d squared y dx squared is equal to, and I'm literally just copying it from the formula sheet, guys, so you can kind of see what's happening, and it's multiplied by dt dx again. So basically, the second derivative of this is going to be dy dx differentiated with respect to t. So now that was 18t cubed, which means 18 times 3 is 54, and we're going to get 54 times t squared. Once we do that, we also have multiplied by dt over dx, which is t over 1, and simply we're going to get 54t cubed as d squared y and dx squared. Now remember that this d squared y dx squared is equal to 2, so we can actually replace this with 2 and figure out what t is. And that's what we're going to do. We're going to put 2 is equal to 54 t cubed and rearrange it. So we're going to get 2 over 54 is equal to t cubed. So t cubed is equal to 1 over 27. And then I can say t cubed is equal to, t is equal to 1 over 27 to the power of a third. And I guess this is where you kind of go, okay, so rather than putting this in the calculator, which you can if you want to, and I guess it'll still be the kind of like the same thing. So I'm looking for the third root, so 3, shift that of 1 over 27. And it's giving me 0.33, so you can see it's 1 over 3. So t is equal to 1 over 3. Now, if you look at it, we can actually figure out what the point for p is, because the coordinates for p is x and y. But x is actually equal to ln of t, and y is equal to 6t cubed. So we can actually replace p with ln of 1/3, and then we've got 6 times 1/3 to the power of 3. Just checking everything. Hold on. Yeah, no, looks good so far. And then 6 times 1/3 to the power of 3. You could leave it like that, or if you really want to, you could also just work out what it is. So 1 over 3 to the power of 3 equals to that, multiplied by 6 equals to 2 over 9. So you can actually rewrite this p as ln of 1 over 3. What a break for him. So yeah, where were we? ln of 1/3 and 2/9. Yeah, apologies guys. I know I got a bit of doing a double duty today of keeping an eye on him and doing this, but it's working so far. Only 2 interruptions. 2/9. Cool. Yeah, that's basically it for this question there. I actually think this question is actually a lot more straightforward for an excellence compared to the previous one. Previous one, I think it's too easy for an excellence. This one is even more easy for an excellence. So, yeah, grade wise, final grade right there is, I was thinking of 2 T's. Ah, I see. Right. I'll show you guys what I'm talking about. Like this one, what they've done is, so question 1D, they've got it as excellence. Question 1E is also excellence, but then if you look at it for E8, you actually need to get both of those questions to get 8 points, which is a bit strange to see in a calculus. I've not seen a question like that in a long time. But anyway, so let's go back to our grading system there. So what do we got? We got correct solution with correct derivatives is an excellence. This right here is going to get you a merit, and a correct equation for dy dx is going to get you an achieved. Cool, guys. That's basically it for this question right here. Cool. So question 3, yet again, we are starting off with a nice differentiation question. So we're going to differentiate this. We've got 3 multiplied by 1 over x squared minus 1. And of course, don't forget to multiply the differentiation of x squared minus 1, which happens to be 2x. And we can leave our answer like that. That's basically it. Achieved. It's funny, right? Like the first, whenever I look at these level 3 calculus papers, like the first 2 questions, I end up finishing in like 5 minutes, less than 5 minutes for the whole paper. But then the other questions just take like immense amount of time. Anyway, going on to the question B, what have we got? We are trying to find when it has a gradient of 1. So we're going to differentiate and then put it equal to 1 to try and solve for x. So our f of x, just going to write that down first, 2x minus 2. And I'm going to put this as x to the power of half just to make it easy for me when I differentiate. So when I differentiate, I'm going to get 2 minus 2 multiplied by half, x to the power of negative half. So now I want to know for what value of x does it have a gradient of 1. So basically, f dash of x equals to 1. What is x? So I'm going to put 1 equals to 2 minus 2 times half is just gone, which means we got x to the power of negative half. Rearranging this, what have we got? Let's take the x to the negative half to the other side, which means it'll become positive, equals 2 minus 1. And I've got x to the power of negative half is equal to 1. Yeah, well, then x is just equal to 1, isn't it? Because we're going to get x is equal to 1 to the power of, well, I mean, I'll show you guys the long method of doing this. The long way of doing this is 1 over x to the power of half is equal to 1, and then 1 over root x is equal to 1. Therefore, root x is equal to 1, and then x is equal to 1. The root x equals 1, I just cross-multiplied there, folks. That's why I kind of went through that fairly quickly. Grades-wise, you've got to get that final answer for achieved with a correct derivative. So you do need to get this line and also get your answer as well. Cool, let's go to question C. Okay, so what we've got in this question is normal to the graph, blah, 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 0.43. So I'm assuming this point right there is 4.3. Intersects the x-axis at point P, find the x-coordinate of P. So what we're going to do is we need to figure out what the gradient is in this case. Then we got to figure out the normal, so negative 1 over the gradient, and then put it as equation of a straight line, and we should be pretty much good to go. So we've got y is equal to 2x plus 1 to the power of half. So y dash is equal to a half multiplied by 2x plus 1 to the power of negative half. I want to find the gradient at 4. So I'm going to have half 2 times 4 plus 1 to the power of negative half. And then f dash of 4 is equal to a half multiplied by 9 to the power of negative half. Whatever that is. Let's kind of work it out quickly. 0.5 multiplied by 9 to the power of negative 0.5. So 1 over 6. I feel like I'm missing something here. Something's not right. I think I know what I missed. Yep, I missed the differentiation of this right here. See? I gotta multiply this by 2, which means there's gotta be another 2 there. That's better. 1/3 is what I'm looking for. So f dash of 4 is equal to 1/3. So 1/3 is the gradient looking on the blue line right now like this. And if I want the normal, normal is -1 over m. So I'm going to get here as -1 divided by 1 over 3. I'm just going to put that as mn, which is normal gradient. I'm going to get it as -3. So now the gradient is -3 and the point is 4 and 3. I'm going to put it as in a straight line equation. Y equals y1 times m times x minus x1. So I've got y minus 3 equals -3 times x minus 3. 4, sorry. Then I've got y minus 3 equals -3x plus 12. Y is equal to -3x plus 12 plus 3. Y equals -3x plus 15. Now for point P, they're asking for the x coordinate. I know the y coordinate is equal to 0. So I'm going to substitute 0 in this equation. And I'm going to get -3x plus 15. And I can pretty much see that x is going to equal 5. And that's basically it for this question. So correct solution with correct derivative must have correct gradient of normal to justify x equals to 5. So you do need this thing to get a merit. Correct derivative gets you an achieved. Now obviously with me, I probably would not have got achieved because I stuffed up that, forgot that multiplied by 2. Even though at the start of this tutorial I did say that people tend to forget that part. Cool guys, that's basically it for this question, and let's go to question D. Cool, so we got a classic question which is just differentiate, put it equal to 0, and then figure out whether there are maximum and minimum points. So I'm going to start differentiating it first. So f of x is equal to, I'm going to bring that x minus 3 to the numerator, so it's going to be x minus 3 -1 plus x. Then f dash of x is equal to -1 x minus 3 -2. Now luckily the differentiation of inside the bracket is just 1, so I don't have to worry about it, plus 1. So I can rewrite this as f dash of x is equal to 1 minus x minus 3 to the power of -2. So I need to put this equal to 0 because that's what gives me for stationary points. So I've got 1 minus x minus 3 to the power of -2 is equal to 0. I'm going to rearrange it. So I'm going to get x minus 3 -2 equals +1. I'm going to get rid of the 2 to the denominator. So it's going to become x minus 3 to the power of 2 equals 1. Cross multiply. And I get x minus 3 squared is equal to 1. Square root of 1 is plus or minus 1. So square root of 1 is equal to x minus 3. So I'm going to get x minus 3 is equal to plus or minus 1. So my first answer is going to be 3 plus 1. And my second answer is going to be 3 minus 1. So x is equal to 4 and x equals to 2. So these are my two values of x for the stationary points. Now I'm going to double differentiate to try and figure out which one is the maximum and which one is minimum. So I'm going to use this thing right here. From there, I'm going to go f double dash of x. 1, when I differentiate 1, it becomes 0. Negative times negative 2 is positive 2. X minus 3 to the power of negative 3. And again, I don't need to worry about inside of the bracket because when I differentiate it, I just get 1. So I need to figure out what f double dash of 4 is and f double dash of 2 is. So for 4, I've got 4 minus 3 to the power of negative 3. And for 2, I've got 2 minus 3 to the power of negative 3. So for the first one, I am going to get so I've got 1 to the power of negative 3, that's just 1, and then we've got 2, and then here we've got negative 1 to the power of negative 3. Negative 1 to the power of negative 3, it's just going to be negative 1, and then that's going to be negative 2. So from this, I can say that f double dash of 4 is greater than 0, therefore minimum point. And f double dash of 2 is less than 0, therefore maximum point. Fairly straightforward excellence question, but it looks like it's one of those questions with double E questions. Yep, it is. So grades wise, with the use of turning points, so that's going to get you an excellence to use the double second derivative test. Correct expressions for dy, dx, and d squared, y, and dx squared. It's going to get you a merit. So that's getting this and the f dash of x. But if you just get f dash of x, then you get an achieved. Yeah, it's definitely not a hard excellence question. Again, it's just a bit of work to do here. All right, guys, let's go to the last question. The last question, it's a proof question. So all it is just looks like you're just double differentiating it and then simplifying it. That's all. There is no other way to do this apart from trying to do this the long method. You could actually end up doing like really long methods. So sometimes it's kind of worth trying to figure out some shortcuts here and there. But yeah, look, let's just have a go at this. I don't think we can escape the product rule right there at the start. So you've got u is equal to 3x plus 2 and v is equal to e to the power of negative 2x. So u dash is equal to 3, v dash equals negative 2 e to the power of negative 2x. So my dy dx is equal to u dash v plus uv dash. So I've got 3 e to the power of negative 2x plus 3x plus 2 multiplied by negative 2 e to the power of negative 2x. And I'm going to be honest with you guys. Like looking at that e to the power of negative 2x as a common factor, take it out, and let's see what we can actually do inside that other bracket. So we're going to get 3 plus 3x plus 2 multiplied by negative 2. So I'm going to work that inside of those brackets first. So I've got 3 minus 6x minus 4. So I'm going to end up with e to the power of negative 2x is negative 6x minus 1. Now I got to differentiate this again to get d squared y and dx squared. So to differentiate this again, I've got to do product rule again. I've got u and v. So u is equal to e to the power of negative 2x. U dash is equal to minus 2 e to the power of negative 2x. V equals negative 6x minus 1. And v dash is equal to negative 6. So with that in mind, we've got d squared y dx squared is u dash v plus uv dash. So u dash is negative 2 e to the power of negative 2x. So far so good. Multiplied by v, which is negative 6x minus 1, plus u, which is e to the power of negative 2x, multiplied by negative 6. And once again, I'm going to do the same thing as I did before with the e to the power of negative 2x. I'm going to take it out as a common factor. And when I take it out as a common factor, I've got negative 2, negative 6x minus 1, plus negative 6. So simplifying that bracket, minus 2, that's 12x, negative 2 and negative 1 is plus 2, minus 6. I end up getting e to the power of negative 2x, 12x minus 4. Cool. So now I'm actually going to go back to the proof and actually prove that d squared y dx squared plus 4 times dy dx plus 4 times y is equal to 0. So my first step is this one here, is that part there. My second thing is dy dx, which is here. And then finally, my y happens to be that block right there. So let's actually put that all down. E to the power of negative 2x, 12x minus 4 plus 4 times e to the power of negative 2x minus 6x minus 1 plus 4 times 3x plus 2 e to the power of negative 2x. So as we did from the beginning, we're going to actually take all of the e to the power of negative 2x's out of the as a common factor. So when we take that all out, what we left over with is 12x minus 4 plus 4 times negative 6x minus 1 plus 4 times 3x plus 2. So expand the brackets out and still leaving the e to the power of negative 2x outside. We're going to get 12x minus 4 minus 24x minus 4 plus 12x plus 8. And e to the power of negative 2x, well, here we go. It's actually starting to make sense. 12x is 24x. 24x minus 24x is 0. Minus 4 is minus 8, plus 8 is 0. And so this is equal to 0. So what we basically did is we've just proved, we've actually just proved that. Like 0 is equal to 0. So this, I guess, I'm kind of stumped here because I'm like, we know this is what the proof is asking, so we proved it. QED. Sometimes people put like little squares. Cool, guys, that is basically it for this question here. So grades wise, let's have a look. Correct solution with correct derivatives gets you an excellence. So basically the final proof gets you an excellence. This right here gets you a merit. This right here gets you an achieved. Yeah, it was actually not a bad paper. Just it was fairly straightforward. I do apologize about the interruptions from my little fella there. Yeah, just trying to keep him busy at the same time as doing this as well. So guys, just a bit of a heads up with your exams, right? Like I always say this, have a go at all the questions, especially with differentiation. If you don't know anything of how to approach the question, just differentiate. Just differentiate the function and you end up walking away with like 2 points from that if you ever need it. So yeah, that's basically my advice for differentiation. Differentiate everything, even if you don't know how to answer the question. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.